In order to make a rational expression into simplest form, you have to factor the top and the bottom first, and then cancel out any common factors. We want to make sure that we state the domain restrictions, which is what x cannot equal. So since we have fractions here, we're not allowed to have zeros in our denominators. So anything that's going to make the denominator 0 is going to be a domain restriction. So in the first one, we can't factor since we only have a monomial on the top and a monomial on the bottom. So what we're going to do is just reduce. So 24 over negative 6, that can reduce to negative 4. X cubed over x squared, we can subtract the exponents and we're left with just x. And then y squared over y cubed, we can subtract those exponents and we get y to the negative 1. And we know that negative exponents must go in the bottom. So this is really going to be negative 4x over y. So this is our simplest form. And then our domain restrictions, we're basically setting the denominator equal to 0, and whatever that equals is our restrictions. Since we have variables that are getting multiplied together, they're just going to equal 0. So we'll say that x cannot equal 0, and y cannot equal 0. So those are our two domain restrictions. Now in the second one, we can factor the top and the bottom. So in the top, we want to factor x squared plus 2x minus 8. So what's going to multiply to negative 8 and add to positive 2? So we can use 4 and negative 2. So x plus 4 and x minus 2. In the bottom, we want to see what multiplies to 6 and adds to negative 5. So we can use negative 3 and negative 2. And since both of these had a values of 1, we could just use our shortcut. So now that we have them factored, we're going to cancel out the like terms. So as long as they have the same terms in the top and the bottom, you can cancel them out. You cannot cancel things that are next to each other. So x minus 2 and x minus 2 are the same, so they're gone. So we're left with just x plus 4 over x minus 3. So that is our simplest form. Now when we are stating our domain restrictions, we're going off of anything that was in the original denominator. So even though we canceled out x minus 2, it still is part of the original denominator. So we're going to set both of those equal to 0. So we're going to take x minus 3 and set that to 0. So x cannot equal 3. And x minus 2 we're going to set to 0. So x can't equal 2. So our two domain restrictions, x cannot equal 3 or 2. In the last one here, it's just written a little bit ugly for us. So in the top, we can rearrange the order and make this negative 4x plus 12, because we're used to seeing the x's first. So from here, we can factor. So the top, we're going to look for a GCF. So we can take out a negative 4, and we're left with x minus 3. The bottom is difference of squares. So that's going to be written as x plus 3 and x minus 3. Once we have everything factored out, we're going to cancel out the like terms. So x minus 3 and x minus 3 are gone. So our simplest form is negative 4 over x plus 3. And our restrictions, x cannot equal, so we're going to look at the denominator, which is x plus 3 and x minus 3. So even though we canceled it out, we're still going to use that as a restriction. So x can't equal negative 3 or positive 3. So if we look at a couple more, again, this first one, we don't have to factor, we're just going to reduce it. So I'm going to reduce 5 over 15, and there's a negative in front, so that's going to become negative 1 over 3. Then the x cubed and the x on the bottom, I can subtract 3 and 1, and that gives me x squared on the top. And then I have y over y cubed, so I'm going to subtract 1 minus 3, which is going to give me a negative 2. Now the negative exponent is going to go to the bottom, so I have on the top a negative x squared. On the bottom, I have a 3y squared. And to find our restrictions again, we're going to take whatever was in the bottom and set it to 0. since there's no adding or subtracting here, and this is just a monomial, what we're going to do is just set each variable to 0. So x cannot equal 0, y cannot equal 0. And those are our two restrictions. In the second one, we have 6c squared plus 9c. So we're going to take out a GCF. Our GCF here is going to be a 3c. So we're left with 2c plus 3. And then we have a 3c on the bottom. So we can cancel out the 3c's, and we're left with just 2c plus 3 as our simplest form. We take what was in the bottom, which is the 3c, and we set that to 0. So c cannot equal 0. That's our domain restriction. And for this last one, we have to factor. So what multiplies to 16 and adds to 8? So we can factor that to be x plus 4 and x plus 4. And on the bottom, what multiplies to negative 24 and adds to negative 2? We can use negative 6 and positive 4. So here we have 3x plus 4's. We can't cancel all of them out. You can only cancel things in the top and in the bottom. So as long as they're on different levels, you can cancel them out. So this 1x plus 4 can cancel with this 1x plus 4. I can't cancel out the other x plus 4 because it doesn't have a buddy in the bottom to be able to cancel. So what we're left with now is just x plus 4 over x minus 6. That's our simplest form. And then we take our original denominator and we set it to 0 for our restrictions. So x cannot equal 6, x cannot equal negative 4.